We present Shape Your Body, a method for robot design using value gradients from multi-embodiment reinforcement learning. Deep learning methods have revolutionized control and decision-making in robotics by enabling policies to learn complex behaviors in a data-driven manner. But can we do the same for designing robot hardware? We first train a single generalist policy and value function across a broad robot distribution. These neural networks are embodiment aware. That means they take in physics parameters of the robots as part of their inputs. After training, the value function is frozen and reused as a differentiable surrogate. Our search method, called Value Gradient Design Search, or short VGDS, optimizes the parameters of new robot designs by differentiating through the value function with respect to the embodiment parameters and updating them. Finally, to deal with approximation errors and to ground the design process, we apply a soft trust region for the gradient updates around the reference design. We train our policy and critic in the largest scale experiment on training sets of up to 50 robots, with 15 quadrupeds, 31 bipeds and humanoids, and 4 hexapods. We add massive embodiment randomization over masses, inertias, geometry, joint limits, PD gains, actuator properties, and much more, to make the embodiment distribution as wide as possible. In the first experiment setting, we only considered a single robot design case. We train one policy and critic per target robot, then optimize perturbed designs of that same robot. Across the Unity Go2 quadruped, the MIT humanoid, and the Golem hexapod, VGDS matches or outperforms strong surrogate search baselines, including Bayesian optimization, CMAES, particle swarm optimization, and many more. Next, we compare our method to adapted RL-based co-design baselines. VGDS reaches similar or slightly better final return, but the main difference is the design cost. RL baselines train a new policy for every initial design, while VGDS trains only once. After one 7 to 9 hour training run, each additional design takes only 1 to 2 minutes of search. Finally, we train reusable policies and critics on morphology class robot sets, so training sets with only quadrupeds, humanoids, or hexapods with the target robot held out. We also train on the full 50 robot set. With all 50 robots, VGDS consistently improves beyond the nominal robot designs of the manufacturers. Here you see a gallery of different initial robot designs, all controlled by the same generalist RL policy and optimized for 10 and 50 iterations with our value gradient design search. Here you see an example design search for the Fourier G1T2 and the MIT humanoid. Here you see an example design search for the Unity Go2 and the Golem. And finally, here you see an example design search for the K-Bot V1 and the Animal C. You can try out and play with our policy and many VGDS designs for different base robots, for quadrupeds, humanoids, and hexapods in our browser-based interactive demo on our project website, which you can find under this QR code. Besides optimizing complete embodiments, we show that the same value function can also be used as a design analysis tool by using its gradients to identify performance-limiting embodiment parameters, such as actuator torque and velocity limits or body part masses. These gradients can also provide insight into the control setup, for example by indicating how PD gains should be adjusted for a given robot, or which nominal joint positions should be chosen for best policy performance. We were happy to present to you Shape Your Body, a method for robot design using value gradients for multi-embodiment reinforcement learning.